So let's look at case 2, which is solving side-side angle triangles. So when we're looking at case 2, which applies to triangles for which two sides and the angle opposite one of them are known, this is referred to as the ambiguous case, because the known information may result in one triangle, two triangles, or no triangles at all. And of course, we're going to work through an example of each. Here's how it could result in two triangles or one large triangle. So let's go ahead and solve the triangle. A equals 2, C equals 1, and C is 50 degrees. So I'm going to always sketch a picture because I am a creature of habit. So I want to start out by figuring out maybe A, because I know what angle A, because I know what side A's length is. So if I have sine of A over A is sine of C over C. So I get sine of A over 2 is sine of 50 degrees over 1. So I get that sine of A is 2 sine of 50 degrees once I simplify. So I get that sine of A is 1.53. But wait, if you try to take the sine inverse of this, you're going to get an error. Why? Well, think about way back, chapter 5, when we started graphing cosine and sine. Can sine ever be greater than 1? No, because we have no triangle. That's what we're going to get, no triangle, because sine is greater than 1. So there can be no triangle. No triangle. Does that word look like triangle? Sorry, triangle with the given measurements. No real triangle can exist. Next, let's solve the triangle given that A equals 4, B equals 3, and A is 60 degrees. That should just be the length B. Sorry, B is 3. B, C. So we're going to start by finding, first we're going to switch from this angry color. Okay, there we go. So let's start out by finding B, because I know the length of side B. So I have sine of A over A is sine of B over B. So I have sine of 60 divided by 4 is sine of B over 3. So sine of B is 3 sine 60 degrees over 4, which is about 0.065. Sorry, 0.65. So if I take the sine inverse, right, of 0.645, that gives me 40.5 degrees. But remember, sine inverse occurs in quadrants 1 and in quadrant 2. So I need to account for a possible another length. So here I have B1 is 40.5 degrees, but I also have to check for B2. B2 is 180 minus 40.5 degrees. So B2 is 139.5 degrees. Now, remember, all the angles of our triangle must add up to 180 degrees. Well, B2 plus A, 139.5 plus 60, is greater than 180 degrees, which means it's not a triangle, right? Triangles equal 180 degrees. So we're only going to have one triangle. This is our only possible B. So B is 40.5 degrees. Now we can use this information to find C, because 180 degrees is A plus B plus C. I get 180 degrees is 60 plus 40.5 plus C, so we find that C is 79.5 degrees. Now I can find length C using the sine rule. I have sine, let me switch colors so we can see it. Sine of A over A is sine of C over C. We substitute in everything we know. This is going to give me that C is 4 sine 79.5 degrees over sine of 60 degrees. That's supposed to be an arrow, which is about 4.54 units. So C is about 4.54 units. Thus, we have solved this triangle with one solution. Our last example had no solutions. I bet you can't guess how many solutions our next example is going to have. And if you guessed 2, you'd be correct. So let's go ahead and work through example 5 before we start looking at some what I believe are applications. So I have A is 7, B is 9, and A is 40 degrees. So I need to find little c and then angles A and B. Well, a great place to start would be with I labeled everything wrong in this triangle. Was I thinking? Probably not. Okay, this is B. This is C. I know A. A is 40. Because I know length B, I think finding angle B would be the best place to start. I know sine of A over A is sine of B over B. So I have sine of 40 degrees over 7 equals sine of B over 9. So we'll have sine of B is 9 sine 40 over 7, which is about 0.83. It's less than 1, so we know we have a triangle. Sine inverse of 0.83 gives me 55.7. So that's my B1 is 55.7. And A plus B1 is still less than 90 degrees, so we know it'll work. I'm also going to have a B2, which is 180 degrees minus 55.7 degrees. That is 124.3 degrees. 124.3 degrees plus A is still less than 180, so I have 2 possible triangles. So I'm going to have to find, using B1 and B2, I'm going to have to find C1 and C2, the angle C1 and C2. So C1 equals 180 degrees minus 40 degrees minus 55.7 degrees. So I have C1 is 84.3. I find C2 in the same manner and find that C2, which is 180 degrees minus 40 degrees minus 124.3 degrees, is C2 is 15.7 degrees. We're going to use this information to find little c1 and little c2. So let's go ahead and find little c1 and little c2. So I have sine of A over A is sine of C1 over C. We substitute in what we know and we find C1 is 7 sine of 84.3 degrees over sine of 40 degrees. If you get lost, this would be a great place to pause and see how I got from this step to this step. It was just substitution, but I've been recording for quite a while, so I'm sure you can handle that on your own. Then for C2, sine of A equals sine of C2 over C2A. So I'd get C2 is 7 sine of 15.7 degrees all over sine of 40 degrees. And I get that's about 2.95. So that's my C1 and my C2. So what's happening here? Okay, so I have a triangle. Angle A is, I have 2 triangles, okay? I've got my angle C2 and I've got my angle C1. So this is length C2. This whole thing is length C1. And I've got 2 different B's, but just one A. Here's my A. Here's B2. So here's length B2. Here's length A. This is also length A, lowercase a. And then here's my B1. So that makes this my B2, sorry. And then this is also A. So that's what's going on, and that's why we got two possible triangles.